Hi everyone. So here we are going to solve question 13 to question 16 of exercise 2.2. So let's start with this question. This is the 13th question and you can move second term on the right side of equal sign and what you will get is plus 1 raised to power 3 e raised to power minus y x minus x dy, and on this side you will have e raised to power y plus 1 raised to power 2 e raised to power minus y dx. Now if you see, there are actually two terms, the terms of x and terms of y in this question, and this side is a term of y and this side is a term of x. You need to move this term here and you are supposed to move this term here. So we can do it directly by, let's say I'm moving this from here. Okay, I want all the signs of constant, all the constants with this term of x, so that is why I am moving that minus sign here. That is actually a minus 1 as a constant multiplied by this term, so I am keeping it on the left side, and this e raised to power x plus 1 and 3. When I move it from here to here, nothing changes but just the sign of power. I can say there is the only change in the power, so you get minus 3 instead of 3 here. And when you move this e raised to power negative x here, you will get e raised to power x here and this thing. And when you similarly, when you will move these terms of y here, you will get e raised to power y plus 1, same term, just with a minus 2 here, and e raised to power y here dy. Now next step is to integrate both sides. I am keeping this minus sign outside of it, and e raised to power x plus 1 raised to power minus 3 raised to power x dx equals to e raised to power y plus 1 and minus 2. Here you have same term. Okay, I forgot the sign of integration here. You have separated the terms now, and after integrating you will have minus 3 plus 1. I am actually applying the power rule of integration. So minus 3 plus 1 will be minus 2, and you need that number in denominator also. So you can multiply this term instead of that. So e raised to power x plus 1, and here you will have minus 3 plus 1, and constant of integration will be written with this side, as that is, I think, dependent independent variable sort of thing is involved here. And when you will integrate this side, you will get 1 by minus 1, since minus 2 plus 1 is this thing, and this thing will be multiplied with e raised to power minus plus 1 raised to power minus 1. So okay, simplifying this, you get 2 here, you get e raised to power x plus 1. Okay, not minus 2, it will be plus 2 here, plus c, and here you will get a negative term with e raised to power y plus 1, and this is your solution. And here we have the 14th question, and it is a very straightforward question. You just need to move this term, this 1 plus x square and the square root of this, on this side with this x, and you need to move this 1 plus y square and the square root of this whole term on this side. So when you will move this term on this side, you will get a y here, and 1 plus y square, and the whole power will become negative and dy. And when you will move this 1 plus x square and the square root of this whole term on this side, you will get its power as, nothing will change except the power, which will become negative, and this thing. Now you just need to integrate both sides, and I can rewrite this thing as, okay, let's take integration sign here and see, 1 plus x square minus 1 by 2. Here I have x. I'm moving this x on this side, and dx. Similarly, on this side, you need a sign of integration. You need the term inside this, and okay, and square root of this, and now I have y and dy. Okay, I have uh, rearranged those terms. Why? Because so that I can apply power rule here. So for applying power rule, I want 2 here, and since I have square of x inside this, and I want a 2 here, for that what can I do? I can divide the same term with 1 by 2. Same thing is here. And another thing that you may see, I can divide this term with this, since that was outside the integral and it was possible. So from here you can apply the power rule on both sides. So what you will have after applying the power rule, 1 plus x square, you will get minus 1 by 2 plus 1 here, and a constant here. Similarly, you will have 1 plus y and minus 1 by 2 plus 1 here. And you know that this thing is actually 1 by 2. 1 plus x square raised to power 1 by 2 plus c equals to 1 plus y raised to power 1 by 2 here. And this completes the problem. Here you have your... Alright, here we have 15th question. But within this question you might get confused about the terms you need to separate. Since the variables are new here, so you can understand it by ds and dr. I am keeping this ds here, and I am keeping this dr here. So I have this ks. I will divide this ks on this side. Okay, let's keep our this s here and k on this side. So you will have k dr here. Now integrating both sides, you can integrate it like this: ds equals to integration of k dr. So k is constant. So integrating both sides, what I get is a natural log of s here, and that is equal to I can take this k as a common outside of it, and I will have just an r because I'm integrating with respect to r. And let's say I keep this constant on this side. Since I kept the other constant k on with r, that is why I'm keeping the constant of integration with this side. So now you have got this solution, but this is not the solution which is given in the book. How can you get the solution according to book? You need to take anti-log here. So you can write taking anti-log. Anti-log, you will get s here, and you will get e raised to power kr plus c here. And now s, you can rewrite this term as e raised to power kr multiplied by e raised to power c. And what is e raised to power c? It's actually a c. It's a constant. It's a constant. You can write e raised to power kr multiplied by c, and you since the commutative property holds here, I don't know how. Okay, so you can move this c here, and you can write c raised to power ekr equals to s, and this becomes your solution. Okay, a similar question, question 16. Again, you need to be a little bit careful about the variables you need to separate. So here k is a constant, and dt and dq tell that q and t are the variables. You need to keep dq here, and you need to have dt here. So since it involves q, I can write it here, q minus 70, and I will keep my constant k here, so I'm keeping it here. And I should make it look like an equation. So there must, the distance within these two terms should not be like this. So you can keep it here and you can keep this whole thing a little bit close to it, so like this. Okay, and now the next step is just to integrate both sides, and you can also make it like q minus 70 raised to power minus 1 dq equals to k dt, and now integrate both sides. So like previous question, anything with the power raised with the power of minus 1 or in the denominator after integrating gets a natural log like this. And since I am keeping this constant with t, so I will write the constant of integration with this term, that will be k t plus c. And again you need to take antilog on the both sides. You will write taking antilog, you get q minus 70 equals to e raised to power kt plus c. From here, according to the rules of exponential, you can write kt multiplied by e raised to power c. And what is e raised to power c? It's a constant. You can write e raised to power kt multiplied by c, and you can, according to the rule of commutative law, you can shuffle these terms. You can write it as c multiplied by e raised to power kt equal to q minus 70. And I think this is the